So today project is a diabetes analysis project. So firstly, I want to load some libraries like import NumPy as np, Pandas, Matplotlib, Seaborn, and also the inline like import, warning, ignore. So I have used some useful library and some library like the Scipy. So these are the library. Once I will execute this, after loading the libraries, I want to load the data like from Google Files and go back to there and choose the file. You can see the data is successfully loaded. So after loading the data set in Colab, now I want to basically data pre-processing. So df pd diabetes.csv. Very nice. Such a great example. You can see the data we have the pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, function, age, etc. I want to perform and want to describe some data like df dot describe. So this is the describe and the column like how many columns are there. So this is the columns and some basic information and the shape of the data. So the rows and columns are available and to count the values. So how many values are there? So it will count the values. So these are the thing like the data type. Data type it is also very good. Like df dot d type like most of the column are integers and into the float and to check out the null values So there is no null value, data is very perfect. And to check out all the null value. Now the question is that, so I want to fill 0 by nan. So we have the functionality like df.copy, and also there are some column like df copy, and all the columns are there, but I want to apply into some selected column. So after writing this particular command, once I have executed this, now I want to print df copy and is null sum. So you can see some null values are there because the reason is that I have filled 0 by np nan, like nan. And now it is your choice and how many values you want to show. So after printing this null value, I want to find out the largest value. Like df dot and largest, and like top 10, like blood pressure. So it provide me the top 10 blood pressure. Like top 10 blood pressure. And also I want to find out some like variance for the data. And df dot std. So I just want to find out the variance of the complete data. Very good. You can see the variance of the pregnancies and the glucose and all the things. So after the standard deviation, I want to find out the correlation. So CORR, it is a correlation function available into the Python to know the actual correlation of all the. So the pregnancy to pregnancy, the one pregnancy to glucose, the 12, 14% minus the 0.7%. So these are the parameter. The age is also the factor. And at the last, I want to discuss the diabetes function. There are some parameters. So I want to visualize into the matrix chart. like plt dot figure, and to define the size of the figure, and also the print the correlation. So once I want to print this correlation, the complete matrix, it will be there. You can see the matrix is there. So above correlation matrix show into the chart. So after printing this correlation matrix, I want to print the data into the histogram. Then plt show. So it will show all the data set distributions and all the values. Like pregnancies values exist, most of the values 0 to 5, 5 to 10. So it will create the bin of all the similar data set. So firstly, I want to show some column, and there are so many columns are there, like pair plot. So before supplying the pair plot, I want to supply some column, and not the all, some limited column I want to supply. So only the 6 column I want to show, and I supply the column to there. Now I execute this particular command. Very nice example. So into the glucose blood pressure, you can see I have successfully show the data with the help of pair plot. Blood pressure is there, pair plot is there. So there are some 6 column I have visualized. So where the blood pressure is there. So after doing this, I want to find out the correlation BMI and glucose. So now like the seaborne SNS regression plot, like BMI. So I just want to the BMI, the column name, and glucose. So this is the glucose. So this regression plot to use to show the relationship into this manner. So it is a regression plot. So what is the relationship between the BMI and the glucose? So like if those BMI basically exist to 20 to 40, so the glucose level is high. And also to find out this relationship with the help of scattered plot, like insulin and the thickness. dot or the joint plot basically. So the two column basically, the first one is skin thickness and the insulin. So you can see the relationship of the data, like skin thickness and the insulin. So here the data set is high to the 0. So similar into the beginning the data set is high. Like those skin thickness is near about to 50. So insulin is also the high. So I have used the joint plot to show the skin thickness and the insulin. Insulin I will describe. It is very useful when we eat any food. So the insulin will be released. And now if I want to visualize into the bar plot we know very well, used for the statistics point of view. So I just want to supply the two and to apply some PLT plots title, and to also use the PLT dot X label. Into the bar plot you can see it will take little bit time, but it is not visible properly. So I want to take some limited data like 165 to 185. So you can see skin thickness data. So those skin is less, so insulin is high. So this is the visualization of the skin thickness with the help of bar plot. We know bar plot look to find out the and also into the bar. Like similar in some classes I have discussed and some upcoming class I will discuss like box plot. So now I have analyzed the skin thickness and versus insulin. Now I want to analyze the glucose versus insulin bar plot. All the things are similar, but I just want to rename the column. Only this one. Glucose. You can see all the values is there. If you want to decrease the value, like some values are there. If the skin is thickness is high, So the glucose is also there. After visualizing this data, I want to check the outcome of the proper value. The target value is 0 and 1. Like I want to write like 0 means no diabetes, and the 1 means diabetes. So I want to count the outrage. So we have the count plot and to supply the data. Once I supply the data, so the chances of the diabetes is no. And also I want to apply some palette for the colorful concept. This one. It is very useful. And if you pass this thing into the y-axis, so it will be printed to the horizontal. Like outcome of the diabetes is this one. It is less. Very nice. Such a very great example of this one. And again, if I want to visualize all the data into the pair plot, the multivariance analysis, like the pair plot, it will take little bit time. So with the pair plot, you can see all the outcome is there. Outcome means like the diabetes is there or not. Pregnancies, and I want to check out the outlier. Like outcome red, that means indicate yes. So glucose level, like if the glucose is high, so the diabetes can be high. If the thickness is high, so the, and these are the data visualization to all of this. And now I want to show the outlier. So in the outlier, I want to apply the set like all the data. I just want to display all the outlier basically. So in that situation, no need to just supply to df and the box plot simply to this. You can see the outlier is there. I want to supply the 5 and 15. Very, such a very great example. You can see the pregnancy, the outlier is less, but in the insulin the outlier is there. So this is some outlier available into the data set. So outlier of all the column. But if I want to show the outlier of the particular column, like the blood pressure, skin, so it depend on you if you want to visualize the one by one box plot and the glucose and the insulin and up blood pressure. So no need to basically just simply to print the data and to supply the data to X and the column name like insulin. And if you want to display like PLT show, so it is a box plot chart and you can define the fixed size because the chart is taking so much size. So the insulin is there and after that you can visualize the blood pressure and the diabetes, then PLT dot show. You can see all the charts show the outlier. Okay, I just also want to use the PLT dot figure. Such a great example of this insulin blood pressure outlier. So diabetes figure outlier is also there, blood pressure outlier is also there, insulin outlier is also there. Such a great example of this. So want to remove the outlier. So if you want to remove any outlier, so the DF quantile 25%, 75%. So we have the data. So this is the value. So to take the value of the 25% and 75%. So interquartile is basically help to remove the outlier. So I want to visualize with the pair plot this useful example. Chart after remove outlier. like pair plot and this data. It will take little bit time. So you can see before visualizing this pair plot chart, I want to remove the outlier, the Q1 minus 1.5 interquartile, TF 1.1 from any axis. This is the data, and near about so many records are deleted. Then after that, I want to visualize this data here. So after removing the outlier, this is a very useful and beautiful chart. So all the ratio of the diabetes. If I just want to know the overall diabetes ratio, so with the use of the chart, like you can take any chart, I just want to know like the how many people diabetes, yes and no. The chart is very lengthy little bit. So I just want to set the figure size. So this is the overall, and if I want to use the title, overall diabetes ratio, like the overall diabetes is 31%. Count number of this 31%. So overall diabetes is 31% is the diabetes and the number of patients. So now all the EDA process and statistical process and visualization process is completed. So now I want to apply the model. Very good. For the data modeling point of view, you can see now we have the data and overall the data. Now I want to basically drop the particular column like x-axis and the y-axis. df out drop. So I easily find the outcome, like outcome x is equal to 1, outcome is equal to y. So x and the y-axis. So what is this? If you just want to df head, you can see we have the data, pregnancy, glucose, and all the things. And also, if you want to show the df out, you have the data. So now I want to just drop the outcome from this and to store into the x. So in X, we have all the column like pregnancy, glucose, blood pressure, sickness, insulin, BMI, diabetes, pedigree, function, age. And after that, we have the outcome on Y. Now I want to, that is a very important question. Now I want to split the data into testing. So with the sklearn, like test, train, split, I just want to split the data. I have not executed this one. So now I just want to the shape of the data. So to print the shape of the training, print and X, like Y train, comma Y test. So this is the shape of the data. And now class, this is also the important thing. I want to apply the machine learning concept to the accuracy test. Accuracy score and confusion matrix. So firstly, I load the accuracy score confusion matrix. Then from Scikit-learn matrix import and classification report if there is needed. So right now I don't want to use this. I just want to test. I will use this matrix later. Like I want to perform the test, jet test. So sklearn is standard scalar and to fit the data, but there is no need for the standard scalar. Simply use the stat model dot stats. And now I want to use and want to test the extend BMI and extreme age. Very good. So you can see we have the value to the BMI. So after maintaining this one, now I want to maintain the multiple hypothesis testing. So firstly, I just want to install Research Pi and want to import Research Pi. So I later use this. So if you will execute this, so it will first collect and download all the necessary packages. Now we have the data and I want to group by the data. Group by the data. Group by outcome. It just find out the mean only. But I want to count the aggregation like mean, standard deviation, and median. Into the particular column. So after visualizing this data, like you can see the outcome, glucose, mean, median, standard deviation. Now I just want to hold the glucose, the data, like glucose and outcome. Okay. Whenever you want to fetch more than one column, so you have to supply the two. Very good. So we have the two column like glucose and the outcome. So I just want to give the labeling like diabetes means yes and no, and non-diabetes. And I just want to replace this outcome to the diabetes and not. So after doing this, you can see replace the outcome diabetes and the non-diabetes. Very good. You can see the above outcome is 10101 and it is just the outcome. Now it become the diabetes and the non-diabetes.
And also there is also some factors like equal to the diabetes and not diabetes here. RP dot test. So I want to test glucose and the outcome like equal to the diabetes. It is also the very useful. So first of all, I just want to show only this data and want to test it. R, I think the above package name is RP. So this RP basically, RP it is a new library I have already discussed. The research file, I use this library because inside this we have the stat model, so many libraries. So on the glucose and outcome equal to diabetes. Group 2, the outcome equal to non-diabetes. So I have successfully stored into group 1, group 2. So there are some variable like glucose, outcome and combined. So glucose, number of value, mean, standard deviation, standard error, confidence interval, and all the mean mode and the difference from the test, degree of freedom. So it will provide all the statistical value as compared to the previous one, like we have used some Scikit library in the stat model. So it's such a great thing. Now I want to visualize these things into the chart. Very good. Such a great example of this. So with the help of SciPy, I want to visualize it. Visualize the data. So I just want to stat model and after that I just want to display like display using this plot. It is the size of the figure and the glucose basically. Then PLT also. So this is the dist plot. I want to, you can see. So glucose level mostly you can say that 70 to 150, like 100 to 150 is high, but the data is mostly the 50 to 200. This is the glucose level. And density of the data. Very good, such a very good. So after doing this, now I want to apply the regression analysis. So the regression analysis, so I want to build the model. So whenever I want to build the model, some logistic, some accuracy confusion metrics requirement is there, and I want to ready the model like logistic regression and fit the data. Those training data basically I have split it and want to predict. So why predict and model dot predict x test and model score. So if I want to check out my model score, so it is 80% accuracy of my model. Very good. Such a very fantastic example of the regression. But now I want to visualize this confusion matrix into the chart. So to visualize confusion matrix, confusion matrix. So from Scikit-learn and confusion matrix. And this confusion matrix I want to show into the chart. So chart for confusion matrix. This. Okay. I have already used this confusion matrix. There is no need for this one. You can see the confusion matrix of the data. The confusion matrix show the 84% and 90. So 121, 0, 120, 17, and this one. So 80, that is, this is the 84% accuracy of my confusion matrix of the data. Such a great thing. Also, if you want to display the classification report, of my Y and this one. So this is the classification report and very useful. The accuracy of my model 77, precise and recall F1 and the support.